Good morning, students. This is Meraj, and today we are going to study the second part of our video. Here we discuss about some of the things. So before that, we have to recollect the information what we studied last time. So as we know, in our last chapter we studied about the states of the matter and how those states were classified and how we can understand the states. अब जो हमें पढ़ना था, जो लास्ट टाइम हमने पढ़ा है और जो अब हमें पढ़ना है, उसमें हमने देखा था कि ऑन द बेसिस ऑफ केमिकल प्रॉपर्टीज़ हम कैसे क्लासीफाई कर सकते हैं मैटर को. तो हमने पढ़ा कि देयर वॉज pure substances and mixture on the basis of chemical composition, and the pure substances divided in two parts, the elements and the compounds, and the mixtures in two parts, the homogeneous and the heterogeneous. In the next video we studied about pure substances, mixtures, and pure substances and mixtures, that's done, and the homogeneous mixtures and the heterogeneous mixtures. Now we understand the true solutions. In case of true solutions, you have to understand one thing, that all the homogeneous mixtures are known as the true solutions. So basically, we can say that the uniform composition of a mixture is called solutions. So in case of when you study about the solutions, there are two things that constituent that you have to understand before go through this. That is solvent and solute. This is solvent and solute. You have to understand what is the solvent. So in a large amount, if you take something in a large amount, that is called solvent, and it is something it is that is in a small amount or lesser amount, that is known as the solute. So for example, you are making a mixture of water and sugar. So in case of these mixture or solution, what you really need to understand, the water, have you taken the water, that is a solvent, and in case of the solute, that is a sugar. So the material you are dissolving in water, that is known as solute, and in what you are dissolving something, that is known as solvent. Okay, got this point? Now we discuss about something more, the properties of the solvent. So remember one thing, all the properties as we studied in the homogeneous mixtures, all the properties are similar in this case too. So the first and most important, that is a true solution is homogeneous mixtures, and the second thing, the particles are cannot be seen by naked eyes. So you can't see the particles as we studied in a homogeneous mixtures too. The next thing, cannot be separated by filtration and do not settle down when you put them for some time or for a large number of times. So if you put it for 1 day or 2 day, you will find that the particles present in a solution, they will not settle down, so they are completely stable. Remember this, as the homogeneous mixtures were stable. Okay, when you pass a beam of light, you will not notice any path of the light visible. Okay, so this is also one of property of it, so remember this. Okay, all the properties are similar to homogeneous mixtures, so if you remember them or you recall them or understand them, so there is no need to really focus on them too. Now we talk about the colloidal solutions. As we studied the true solutions, we study under the homogeneous mixtures, and if you talk about the heterogeneous mixtures, so there is, you study about the colloidal solution, and the one other one, that is the suspensions. So we study here the colloidal solution. In case of colloidal solution, there is two or more substances were mixed, and this is known as the heterogeneous mixtures, and we know about the heterogeneous mixtures and their properties too. There is example, the mixtures of milk in water, that is one of colloidal solution, and the mixtures of egg albumin into water, that is also the milk, and the air containing dust and smoke is one of colloidal solution. The properties you really need to understand there is a little bit changes, so that these are heterogeneous mixtures, and they also cannot be seen by naked eyes and cannot be separated by filtration and do not settle down, and their solution are stable. In case of colloidal solution, these properties are being completely or a little bit different as compared to we have studied in heterogeneous mixtures. Okay, the properties: particles scatter a beam of light passing through it, and the path of light is visible in the solution. This is the similar property as we studied about heterogeneous mixtures. Basically, the main example that we talk about the colloidal solution, that is about the starch. Okay, the starch in water and the milk. These are very basic example you will understand about the colloidal solution. Even in case of colloidal solutions, when you notice a milk in something, a glass or something, so you will notice you can't identify the particles separately, or even you can't identify them after looking at by your naked eyes. So that is one of colloidal solutions. So it has some of the different properties from heterogeneous mixtures, but it is heterogeneous mixtures. Okay, now we talk about the suspensions. Suspension is also one of heterogeneous mixture, and it is two or more substances when mixed together, then it is formed. Examples are sand in water, easily noticeable. Solution of chalk powder and water, easily noticeable. You can see the every single particles of chalk when it was mixed in a water. And after some time when it settled down, there is two layers separately. You can those were visibles and you can notice them separately. Okay, so one thing, this is heterogeneous mixture, we know very well, and it can be seen by naked eyes. It is also true, and properties can be separated by filtration. The particles can be separated by filtration. Actually, in the lab, what happened? We take a paper. The paper is called filter paper, and when you flow the water or the any of the suspension on it, you will notice the water will completely separated from the mixture, and only these particles, those were visible, they will be in a other side of that filter paper, and you can notice them very easily. Okay, the solute particles settle down and the solution in is unstable. So in case of it, after some time you will notice it is divided in two complete parts. So two complete layers you can notice of solute and solvent. The particles scatter a beam of light passing through it, and the path of light is visible in the solution. So you can also notice the path of light that is visible in the solution when a light passes through the mixture or a suspension. Here it is. Properties of the solution. You will notice one and the most important thing, the separation or the filtration. So it's a funnel, and here it is filter paper is fixed, and when you pour it in the funnel, you will notice the water is separated from it. That is known as the solvent. The solvent is separated from it, and the left material, that is in the form of particles, will be here in a funnel. So this is, I'm sorry, that is solvent, that is solvent, and that is solute. Okay, yeah, sure, it is a solute. Up now we discuss about how the particles are visible and how it is unstable. So when you put it for some time, you will notice that there is two complete layers. Two complete layer will be separated very easily. So the solvent will be upside and the solute will be downside. Actually, it depends on density that we discuss in next video. Here, the second thing, when a light passes through, it show a path. So completely and clearly visible path can be seen. Actually, the smallest particle they were found in the suspension, or when the light hit on them, so it reflected, and due to that you will notice that there is a complete clear path visible over there. Okay, now we talk about the Tyndall effect. Actually, what is the Tyndall effect? It is generally, as we were studying the clear path, or the path you notice in that is known as the Tyndall effect. So when a beam of light is passed through a colloidal solution, the colloidal particle scatter the beam of light and the path of the light becomes visible in solution. This effect is called Tyndall effect. Okay, the path that is visible, that is called the Tyndall effect. Actually, this it was discovered by the one of scientists, his name was Tyndall, so it is known as the Tyndall effect. The Tyndall effect can be seen when light entered a room through a small hole due to scattering of light by the dust and the smoke particles. You can notice is when the sun rises, or you notice that the rays of the sun are coming through a hole or the window, so there is the particles can be visible, so that is also called the Tyndall effect. Tyndall effect can be seen in a dense forest due to the scattering of light by water droplets in the mist. So it is visible in villages, there are a lot of the trees, so due to darkness, some of under the tree, or the lights were coming from ports, or like some kind of halls, so you can notice there the particles, visible particles. Okay, in the next slide, all the slides, the Tyndall effect. This is also Tyndall effect. It is Tyndall effect, and from the window that you can notice in your home, it also a Tyndall effect, example of a Tyndall effect. Now we discuss about the saturated solutions. Actually, the saturated solution is a solution which cannot dissolve any more of a solute at a given temperature. When you start a process and you try to dissolve something in a solvent, you notice after some time that the solute you are mixing stopped dissolving in that, and that is called the saturation point of that material or that solvent. So a limited amount of of the solute can be dissolved in something, and that is known as the saturation point, or that solution is known as saturated solution at a given temperature. If you increase the temperature, then the mixing power, or the dissolving power of that solvent will increase definitely. Solubility, what is the solubility? So in case of solubility, you have to understand, it is of a substance is amount of a solute present. It depends on how much amount of a solute present in something, that is called the solubility of that solvent. Okay, in a saturated solution of a substance. Okay, unsaturated solution के case में you have to understand कि if you dissolve a less amount in something, that is known as the unsaturated solutions. Now we talk about the preparation of a saturated solution. So take 50 ml water, okay, in two beakers. Add salt in one beaker with continuous stirring with no more salt dissolve in it. Even you have to dissolve the salt in it continuously. You are mixing with some spoon or like glass roll. Similarly, add sugar in the other beaker with continuous stirring till no more sugar dissolve in it. You have to dissolve it till the point the more sugar will start settling down in the bottom of that beaker. We get saturated solution of salt and sugar. When it stopped being dissolved, you will get a mixture, the clear mixture or uniform compositional mixture, that is called saturated. If the mixture are heated, dissolve some more of the solute. Even you will start dissolving some more of the solute, so you have to heat it. And when you start heating and you mix some more amount of the solute, so you will find like that will start being dissolved. The solubility of different substances are different. It is also very important actually. Okay, the solubility of different substances are different when you dissolve in something, and the solubility of substances varies with the temperature, and when the temperature changes you will notice the solubility of them will changes according to that. Okay, here we discuss about the concentration of the solution. So actually it depends on the amount of the solvent and how much amount we dissolve as a solute in a solvent, that is called the concentration of it. So the concentration of a solution is the amount of solute present in a given amount of solvent or solution, that is known as the concentration of the solution. So if I talk about the concentration of solution, then so the concentration of solution, amount of solute upon amount of solvent, or in some cases the amount of the solution is taken. The concentration of the solution can be expressed as mass by mass percentage or mass by volume percentage, and sometime volume by volume percentage. Okay, so in case of the mass by mass percentage, we take the mass of the solute and the mass of the solution into 100. So we are taking the answer in percentage over here. The mass by mass percentage, we take the mass of the solute and the volume of the solution. So as for example, we are taking the example of the sugar and water. So in that case we take the mass in gram of the sugar and the volume of the solution, that is because we are taking water, so the it will be the in the form of the volume. So so we take that in the form of volume. Okay, we solved some of the examples and related to the concentration, and I will upload a separate video about for that. So I upload some of the examples, so you try to solve first and then we will discuss about them. Okay. Okay, तो हमारी जो नेक्स्ट वीडियो होने वाली है, हम उसमें थर्ड पार्ट ऑफ दिस चैप्टर हम स्टडी करने वाले हैं सेपरेटिंग टेक्निक्स. Actually, when you have some mixtures, how you will separate them. Okay, so what type of process you will use to separate them. So this is known as the separating techniques to separate the mixtures and from its components from the mixture. So the components of a heterogeneous mixture can be separated by simple methods like hand pickings, sieving, filtration, etc. So in case of mixtures, there are some of the techniques were used to separate them completely from each other. So the first and the most important is evaporation, and we will discuss this complete process in detail. Then centrifugations and decantations, then sublimation and centrifugation, then chromatography, and this is distillation and fractional distillation. Okay, it is two times, so don't worry, we will discuss one time only. Okay, and the next video will be uploaded tomorrow, so be connected, and please, I'm uploading one of worksheet. You have to solve them and just send it back to me. Thank you very much, best of luck, and please study and be at your home. Thank you very much.